Good day, class. In this lesson, we will learn to solve quadratic equations using the square root property. Keep in mind that as we solve quadratic equations, all of these methods are available to us. In particular, factoring, the square root property, completing the square, the quadratic formula, and graphing. You will need to understand the difference in all of these different types of methods and when to employ them. We'll practice that after we learn to use each of the methods. In this lesson, we will learn to use the square root property method. It is important as we use the square root property to always be able to successfully recognize perfect squares. So we have perfect squares up to the number 20 right here on your screen. Let's start with the number 0. We know that 0 times itself is 0. We know that 1 times itself is 1. We know that 2 times itself, or 2 times 2, makes 4. We know that 3 times itself, or 3 times 3, makes 9, and so forth. Therefore, we also know the square root values of these numbers. Let's take a look at 4 and 16, for example. Since 4 times itself makes 16, then the square root of 16 indicates the number that has been multiplied by itself to give us 16. And we know that that number is 4. Therefore, the square root of 16 is 4. Now, secondarily, we'll take a look at what it means when we take the square root of a variable. So here we're looking at x squared, x raised to the second power. Well, that in its fundamental form means x times x. X has been multiplied by itself. That's what it means to square a value. Well, if I take the square root of a value that's already squared, I'm asking for the number that was multiplied by itself. Well, in this case, the number that was multiplied by itself is x. Therefore, the square root of x squared is x. So the beauty of this entire method, the square root property method of solving quadratic equations, is that we can always get back to that basic variable of x or y or whatever variable in which we're dealing if we can just take the square root of it, because it's already a perfect square when that value has been squared. So now we'll move on to some specific examples. Here we have x squared is equal to 4, and your challenge is to identify the number that has been squared to make 4. So you'll take the square root of both sides. So that's all that you have to do, is take the square root of both sides and then simplify, because the square root of x squared is x and the square root of 4 is, now note, I have plus or minus 2 there. And the reason that I have that is because 2 could have been squared to give me 4, and negative 2 could have been squared to yield 4. So we have to keep in mind and even indicate that either of those two values could have been the solution. Remember, quadratic equations have more than one solution. So we're going to go with plus or minus 2 as our solution to this equation. That means positive 2 is a solution and negative 2 is a solution. In this example, it's very similar to our last example, but we have to see it kind of in a provincial light. It's very much like the last example, except that negative 7 is sitting there and it's being subtracted. That 7 is being subtracted from x squared. So if we could just move that and get that over there with the other constant, then we're kind of thinking outside of the box a little bit. We're using our critical thinking skills. And now we have our constants together. We combine those. And this looks very much like the last problem example that we were working on, where we have, in this case, x squared is equal to 16. And then we take the square root of both sides. This is the property that says we can do this. Take the square root of both sides. This yields x is equal to plus or minus 4, because the square root of x squared is x. And the square root of 16, or what number was multiplied by itself to make 16, it could have been positive 4, it could have been negative 4. There are two solutions to this problem that make a true statement. X plus 4, or x is equal to positive 4, and x is equal to negative 4. In this example, we have y squared is equal to 169. So we don't change our minds because we have y, the y variable, of course, but we do note that 169 is also a perfect square, just as y squared is a perfect square. We'll take the square root of both sides. This yields y is equal to plus or minus 13. In this example, very much like the previous examples, except we have a fraction, but we also note that the numerator is a perfect square, the denominator is a perfect square. So we'll go ahead and take the square root of both sides, since this entire problem is just riddled with perfect squares. Now the perfect square, or x squared, when we take the square root of that, yields x, and the square root of 81 divided by 196 is actually plus or minus 9 over 14, because the perfect square of, or the perfect root of 81 is 9. The perfect root of 196 is 14, perfect square root. So therefore, our solution, or the only numbers that will make a true statement for this quadratic equation, remember quadratic equations can have up to 2 solutions. This one has 2. Those solutions are 9 over 14 and negative 9 over 14. In this example, we're asked for the value of x when x is squared and is equal to negative 4. We'll take the square root of both sides, but one thing we cannot do in this lesson, as far as we know right now with all the mathematical knowledge that we have, is find the square root of a negative number, because there's no number that you can think of that's negative that you can multiply by itself that will give you a negative number. There's nothing. Anytime you multiply a negative by a negative, you'll always get a positive. Therefore, this solution there is no real number that will yield negative 4 when you multiply that number by itself. Think carefully. Negative 2 times negative 2 gives us positive 4. So there's no way to get negative 4 when you're multiplying a number by itself. In this example, we don't have a perfect square on the right. 54 is not a perfect square, but we should recognize that there might be a perfect square living inside of there. And sometimes we might actually be asked to simplify it as far as we can possibly go using the square root property. So note that you can wiggle out of this one even by taking the square root of both sides and then still reducing the radical on both sides. So I'm going to take the square root of x squared, it's x, and I'm going to take 54 and split that up into the square root of 9 and the square root of 6, because the square root of 9 times the square root of 6 is the square root of 54. And I like that square root of 9 because it is a perfect square. So that becomes 3. And then we just let the square root of 6 hang out. There's not much more we can do with that. So the number that got multiplied by itself to make 54 is plus or minus 3 times the square root of 6.